Question 1. With respect to a scenario involving centralized management in Cisco data centers, Mr. Haruto, a senior data center engineer, is tasked with deploying multiple service profiles across a UX domain to provision a set of blade servers. During the deployment, he notices that a profile failed due to a MAC address conflict. Upon reviewing UX Manager, he discovers that MAC pool exhaustion has occurred. To address this, he considers adjusting the profile templates or pool configuration. What is the most appropriate step Mr. Haruto should take to ensure seamless deployment and scalability of UX service profiles? A. Disable MAC pooling altogether and assign static MAC addresses manually to each service profile. B. Create a new MAC pool and assign it to the affected service profiles using a service profile template. C. Increase the subnet size of the existing IP pool used for management interfaces. D. Use cloning to duplicate an existing service profile that has valid MAC assignments. Answer. Correct answer. B. Create a new MAC pool and assign it to the affected service profiles using a service profile template. Blue Book explanation. In Cisco UX Manager, MAC pools are used to assign MAC addresses dynamically to service profiles, promoting consistency and automation. If pool is exhausted, as in Mr. Haruto's case, the correct method is to create new MAC pool with larger range or additional capacity and associate it with the service profile template. This allows continued automation and prevents address conflicts. Option A goes against Cisco best practices by introducing manual assignment, which increases error risks. Option C is irrelevant since IP pools are not tied to MAC addresses in UX context. Option D. Cloning would replicate the conflict if the MAC assignment issue isn't resolved. Cisco documentation. Cisco UX Manager CLI configuration guide recommends using pooled addresses with sufficient planning and automated templates for scalable operations. Question 2. Throughout the course of configuring trunk links between Cisco Nexus switches and upstream routers, engineer Luna encountered connectivity issues where certain VLANs were not passing through. After validating physical cabling and switch port trunk configurations, she suspects VLAN mismatches or misconfigurations related to native VLANs. Which of the following is the most likely root cause for VLAN traffic not propagating correctly across the trunk link? A. Native VLAN mismatch on the trunk links between devices. B. Incorrect NTU settings on the router interface. C. Port channels were not configured in LAC mode. D. VLANs were not assigned IP addresses at the router. Answer. Correct answer A. Native VLAN mismatch on the trunk links between devices. Blue Book explanation. When two devices, such as Cisco Nexus switch and router, are connected via trunk link, native VLAN mismatch is a common cause of VLAN propagation issues. Cisco's best practices. See Cisco Nexus 9000 configuration guide highlight that mismatches can cause control plane traffic or untagged frames to be dropped or misrouted. While MTU mismatches B can affect performance, they are unlikely to prevent VLAN propagation. Port channels C are not relevant unless LAC is being used and configured inconsistently. VLANs do not require IP addresses. D unless inter-VLAN routing is needed. A native VLAN mismatch is the most plausible root cause. Question 3. Examining the consequences of improper configurations in converged network adapters, CNAS Mr. Oak is troubleshooting storage connectivity issues in a Cisco UX environment where FCO is deployed. The servers use CNAS connected to Nexus switches that support FCO. Despite correct zoning and LAN mappings, the servers fail to detect the storage targets. After analysis, Mr. Oak realizes the issue lies in the FCO initialization phase. What configuration oversight is most likely responsible for this failure? A. Missing FCO VLANs mapped to vSANs on the Nexus switch. B. Incomplete host configuration on the storage VLAN. C. Absence of dynamic ARP inspection policies. D. Redundant Layer 3 interfaces causing asymmetric routing. Answer. Correct answer A. Missing FCO VLANs mapped to vSANs on the Nexus switch. Blue Book explanation. In an FCO deployment, FCO VLANs must be properly mapped to vSANs and carried across the FCO-capable switches using the FCO VLAN command. Without this mapping, FCO initialization protocol will not function correctly and end hosts will fail to detect targets even though zoning and LUNs are configured. OSP B and ARP inspection C are irrelevant in storage-specific configuration. Redundant routing D may cause network issues but not prevent initial F-code target discovery. Cisco's F-code design guide reinforces the importance of correct VLAN vSAN mapping and FIP initialization for successful F-code operation. Question 4. To illustrate this point, consider a data center where multiple subnets are used to isolate management, storage, and compute networks. A network engineer allocates the subnet 192.168.120.026 for management devices. The UX manager needs to assign addresses to 20 servers, 4 fabric interconnects, 1 KVM management console, and 2 UX chassis controllers. Which of the following best ensures use of address space without exhausting the subnet? A. Reduce the subnet mask to 24 to accommodate growth. B. Assign static IPs to critical devices at AEP for others. C. Use 2 separate 27 subnets for redundancy. D. Divide the 26 subnet into 4 28s to segment the traffic logically. Answer. Correct answer. B. Assign static IPs to critical devices at AEP for others. Blue Book explanation. The 192.168.120.026 provides 62 usable addresses, 64. 2 reserved, which is sufficient for 27 devices. Assigning static IPs to critical infrastructure components e.g. fabric interconnects, UX manager KM consoles ensures deterministic addressing while AEP for less critical servers preserves IP resources. Option A allows for more IPs but defeats subnet efficiency. Option C adds unnecessary segmentation and complexity. Option D creates too small subnets, limiting flexibility. Cisco IP addressing best practices recommend mix of static and dynamic assignments for scalability and manageability. Question 5. Given the circumstances of a multi-tenant data center deployment, Ferreira is configuring Cisco SI to support tenant isolation and policy enforcement. She creates 2 tenants and defines separate bridge domains, BDS and endpoint groups X. However, hosts within each tenant cannot communicate despite being in the SIM-ERF. Which of the following is the most likely configuration issue? A. Contracts were not defined between X within the tenant. B. Bridge domains were incorrectly assigned to the SIM-ERF. C. VLAN IDs overlapped across both X. D. The APIC was not set to Fabric Administrator mode. Answer. Correct answer. A. Contracts were not defined between X within the tenant. Blue Book explanation. In Cisco SI, even within the SIM-ERF, it require contracts to allow intercommunication unless explicitly configured for unrestricted communication. The Cisco SI Fundamentals Guide specifies that policy enforcement is contract-based, which supports micro-segmentation and security. Option B is incorrect since multiple BDS can exist in ERF. Option C is irrelevant unless overlapping VLANs are mapped to conflicting domains, which is not evident here. Option D affects privileges, not tenant-level communication. Question 6. The fundamental question is, in Cisco Nexus data center environments, what underlying protocol mechanism ensures loop prevention in Ethernet networks where multiple layer 2 paths exist? A. Link aggregation control protocol LAC. B. Spanning tree protocol SDP. C. Port fast feature on access ports. D. RAP BVSD plus used only for trunk ports. Answer. Correct answer. B. Spanning Tree Protocol SDP. Blue Book explanation. The Spanning Tree Protocol SDP is the standard Layer 2 protocol to prevent loops by blocking redundant paths, thereby forming loop-free topology. Cisco Nexus supports various SDP modes including RAP BVSD Plus and MSD, which offer faster convergence. LAC-A is used for link aggregation, not loop prevention. Port fast. C. Accelerate port transitions but doesn't prevent loops. RAP BVSD Plus. D is used on all SDP-enabled ports, not only trunks. As outlined in the Cisco Nexus SDP configuration guide, SDP remains critical in any Layer 2 network to ensure topology stability. Question 7. In the context of command line interface differences between Cisco iOS and NAOS, engineer Lorenzo notices that several standard iOS commands are unavailable on a Nexus 9000 device running NSOS. It needs to enable enhanced shell access to perform advanced troubleshooting. Which command is necessary to unlock these diagnostic commands? A. Feature set advanced. B. Enable diagnostics. C. Configure terminal. D. Install feature share. Answer. Correct answer A. Feature set advanced. Blue Book explanation. On Cisco and AOS platforms, especially Nexus 7000, 9000, many diagnostic or advanced commands are hidden unless feature set advanced is enabled. This enables more extensive set of troubleshooting tools. Option B doesn't exist as command. Configure terminal. C is required to enter config mode but doesn't reveal commands. Option D is incorrect syntax. This feature control is detailed in Cisco and Exos Client Management Guide. Question 8. As demonstrated by scalable infrastructure deployments, Cisco UX uses Fabric Interconnects (FIS) to connect to both servers and upstream networks. In a typical setup, which of the following best describes the primary function of the Fabric Interconnects in UX architecture? A. Provide CPU and memory resources to blade servers. B. Aggregate SAN and LAN traffic from UX servers. C. Store firmware updates for UX Manager. D. Host hypervisors for virtual workloads. Answer. Correct answer B. Aggregate SAN and LAN traffic from UX servers. Blue Book explanation. Fabric Interconnects FIS serve as centralized aggregation points for both LAN and SAN traffic within the UX system, simplifying cabling and management. They also host UX Manager for configuration and provisioning. They do not provide CU memory, nor do they host hypervisors. D. Firmware is stored locally on endpoints or distributed via UX Manager, inherently stored in FIS. C. Refer to Cisco UX Architecture Guide for further detail. Question 9. The evolution of SAN environments has introduced new zoning models. Which of the following best describes the advantage of single initiator zoning in a fiber channel SAN? A. Reduces bandwidth by limiting data streams. B. Enhances security and isolation between initiators and targets. C. Prevents device discovery by SC switches. D. Automatically updates zone membership with new devices. Answer. Correct answer. B. Enhances security and isolation between initiators and targets. Blue Book explanation. Single initiator zoning improves security performance and fault isolation by ensuring each initiator HBA can only access its assigned targets. It limits fabric disruptions and is Cisco recommended best practice, especially in large data centers. Option A is incorrect. The goal is not to reduce bandwidth. C is false. Zoning doesn't impact switch discovery. D applies to soft zoning with aliases, not single initiator zones. See Cisco DS SAN zoning guidelines. Question 10. From a practical standpoint, is BIANCHI reviewing syslog messages from a Cisco Nexus switch and notices recurring log entries indicating temperature threshold violations. Which command should she run next to verify real-time temperature data and assess whether the issue is transient or persistent? A. Show environment temperature. B. Show interfaces status. C. Show running config. D. Debug system environment. Answer. Correct answer A. Show environment temperature. Blue Book explanation. The command show environment temperature provides real-time readings of sensed temperatures on Cisco Nexus switches, essential for hardware health monitoring. Option B shows interface link status, not thermal data. C reveals config but not environment telemetry. D is not used for standard monitoring and could disrupt performance. Refer to the Cisco and Exos System Management Configuration Guide. Question 11. Contrary to popular belief, implementing Virtual Device Conx EDCS on Cisco Nexus 7000 switches is not simply a matter of segmentation. It introduces operational challenges and opportunities. Mr. Yosef, the data center architect, is asked to isolate traffic and administrative control between a staging and production environment using the same physical switch. Which of the following must Mr. Yosef consider when configuring EDCS? A. Each VDC must have a separate UX domain. B. DCS share the same control plane and cannot isolate configurations. C. DCS must be licensed and may require role-based access controls. D. EDCS must use the same global routing table. Answer. Correct answer. EDCS must be licensed and may require role-based access controls. Blue Book explanation. Virtual Device Context (EDCS) are Cisco Nexus switches allow logical separation of devices within single physical switch. Each VDC has its own control plane configuration and administrative access. However, VDCS require specific licensing and are back if different teams manage each context. A is incorrect. EDCS is a switch function not tied to UX domains. B is false. Each VDC has its own control and data plane. D is wrong because EDCS operate independently, including separate routing tables. Refer to the Cisco NSO System Management Configuration Guide. Question 12. Taking into account the dynamic nature of SAN environments, ISSING is deploying a new Cisco DS switch and needs to configure it for efficient zoning administration. Her goal is to implement a flexible system where zones can be updated or rolled back quickly. Which approach should she choose? A. Configure hard zoning for strict enforcement. B. Use enhanced zoning mode to allow atomic commit and rollback. C. Set up a soft zone database for informal access control. D. Avoid zone sets and use default vSAN policies. Answer. Correct answer. B. Use enhanced zoning mode to allow atomic commit and rollback. Blue Book explanation. Enhanced zoning in Cisco DS switches allows atomic transactions, meaning changes can be committed or rolled back, reducing the risk of configuration errors. It's ideal for environments where changes are frequent. Hard zoning offers stricter security but not rollback. Soft zoning C does not enforce traffic filtering. Default D without zone sets is insecure and not best practice. Cisco DS zoning configuration guide supports the enhanced zoning model for control management. Question 13. As evidenced by the importance of lifecycle management in UX environments, engineer Mr. Blanco is planning a firmware upgrade on her UX domain with multiple servers. He wants to minimize downtime and avoid service disruption during the upgrade. Which method should Mr. Blanco adopt? A. Perform a disruptive upgrade of the entire UX manager cluster. B. Use the auto-deploy feature to automatically patch endpoints. C. Schedule a staged firmware upgrade using host firmware packages. D. Use out-of-band scripting tools to reboot all servers simultaneously. Answer. Correct answer. C. Schedule a staged firmware upgrade using host firmware packages. Blue Book explanation. Host firmware packages HFPS allow firmware updates to be tied to service profiles, enabling non-disruptive staged upgrades. It's the Cisco recommended method for maintaining firmware compliance. A is disruptive and only advised during maintenance windows. B is not valid UX feature. D causes unnecessary downtime. Refer to Cisco UX firmware management best practices for safe upgrade procedures. Question 14. The prevailing attitude toward virtualization in data centers emphasizes hardware abstraction and workload mobility. Is Tesso's managing UX blades that host several hypervisors running critical applications? Which of the following best represents an advantage of virtualization in this context? A. Eliminates the need for firmware updates on UX blades. B. Allows dynamic allocation of physical switch ports. C. Enables rapid provisioning and live migration of workloads. D. Prevents server overutilization through VLAN segmentation. Answer. Correct answer. C. Enables rapid provisioning and live migration of workloads. Blue Book explanation. Virtualization allows logical isolation of workloads, rapid provisioning, and features like vMotion or live migration, which are critical in high availability environments. A is false. Firmware still needs updates. B is function of switch virtualization, not hypervisors. D misrepresents VLAN's role, that they do not control CU memory utilization. Cisco virtualization guides emphasize workload agility and resource optimization as key benefits. Question 15. Across different scenarios, engineers must decide where to install XC hypervisors within Cisco UX environments. Mr. Rohit has several UX blades available and is setting up a cluster of VMware XC hosts. What is the preferred location to install the hypervisor software? A. On a shared SAN LAN accessed via fiber channel. B. On an USB stick in the KVM console. C. Directly on LOL HED of the blade server. D. Within OM running on the UX manager. Answer. Correct answer. C. Directly on LOL HED of the blade server. Blue Book explanation. Cisco and VMware recommend installing XC directly on local DCTECH for performance, reliability, and management simplicity. SAN-A is possible but not preferred for the hypervisor OS. B is not recommended due to reliability. D is invalid. UX Manager is management interface, no VM host. Refer to VMware XC installation guide on Cisco UX for best practices. Question 16. While examining redundancy models in Layer 2 data center designs, Mr. Calvin notices that some Nexus switches experience erratic behavior during topology changes. Upon deeper inspection, he finds that multiple root bridges are intermittently elected. What best explains this instability? A. Port fast is incorrectly enabled on trunk ports. B. UGuard is preventing SDP convergence. C. SDP priorities are not manually set across core switches. D. Root guard is blocking the root bridge election. Answer. Correct answer C. SDP priorities are not manually set across core switches. Blue Book explanation. If SDP priorities are left at default, 32,768 root election becomes random, causing network instability. Manually assigning low priorities to core switches ensures deterministic root bridge election. Port fast A accelerates access port transitions not relevant to root election. UGuard. B. Edge ports, not core links. Root guard. D. Prevents inferior switches from becoming root. Not the cause here. Cisco SDP design guide advises explicit priority setting for predictable topology. Question 17. The relationship between dual home server designs and switch redundancy is often implemented using VPC. Mr. Nielsen has configured VPC between two Nexus 5000 switches connected to several UX servers. After initial setup, he notices traffic blackholing when one switch is rebooted. What is the most likely cause? A. VPC pair keeplev is missing or failing. B. SDP is blocking one VEC member link. C. Server NIC teaming is set to active mode. D. The VPC domain ID was set differently on each switch. Answer. Correct answer. A. VPC pair keeplev is missing or failing. Blue Book explanation. VPC pair keeplev ensures that both switches in VPC domain remain synchronized. If it fails, one switch may assume the other is down and suspend ports, leading to traffic loss. SDP B should not block VPC links. Active teaming C is supported. Different domain IDs D would prevent VPC from forming at all, not cause blackholing. Cisco VPC design guide emphasizes peer link and keeplev stability for redundancy. Question 18. The development of FEX technology simplifies cabling and switch management in large data centers. Cisco is deploying several Nexus 2300 FEX units connected to a pair of Nexus 9000 parent switches. What key concept allows these FEX units to be managed as remote line cards? A. FEX use VXLAN to tunnel control traffic. B. FEX units have embedded operating systems. C. FEX uses fabric ports to forward data but no control plane. D. FEX must be configured with a separate management IP. Answer. Correct answer. C. FEX uses fabric ports to forward data but no control plane. Blue Book explanation. FEX units are dumb line cards. They forward traffic via fabric ports and rely on the parent switch for control plane operations. They don't run their own OS. B. Nor do they require management IPs. D. VXLAN A is unrelated to FEX. Cisco Nexus Fabric Extended Deployment Guide outlines this model. Operational simplicity and scalability. Question 19. By evaluating long-term switch performance, Mr. Arnold wants to identify bandwidth usage trends on specific interfaces of a Cisco Nexus 3000 switch. Which command is best suited for collecting and displaying historical interface usage? A. Show logging last 24 hours. B. Show interface counters. C. Show policy map interface. D. Show interface stats detail. Answer. Correct answer. B. Show interface counters. Blue Book explanation. The show interface counters command reveals detailed traffic statistics including bytes errors and packets per interface. It's ideal for monitoring usage trends. Logging A shows events, not traffic. Policy map C is used in COS. D is not standard NXS command. Refer to Cisco NXS command reference for correct syntax and use. Question 20. To determine whether a power-related alarm on a Cisco UX chassis is transient or critical is had it checks logs using UX Manager, which log or command provides real-time and historical information about environmental events, including power supply failures. A. Scope chassis show thermal log. B. Scope server show fault. C. Scope power show stats. D. Scope chassis show event log. Answer. Correct answer, D. Scope chassis show event log. Blue book explanation. The event log in UX Manager under Scope chassis shows real-time and historical system alerts including power failures, fan errors, and voltage anomalies. Thermal log A focuses on temperature. Faults B show current system state but not logs. Power stats C show readings, not events. Cisco UX CLI guide recommends event log for environmental issue tracking. Question 21. In the context of selecting hardware for scalability and resource optimization, ISTA Santiago is tasked with recommending server hardware for a data center expansion involving predictable workloads and limited rack space. The workloads require high memory density, efficient cooling, and centralized management. Which hardware platform should he propose? A. Rack servers due to their high port availability. B. Blade servers for their space efficiency and integrated management. C. Tau servers because of their simplicity and low cost. D. Hyperconverged appliances for flexibility and application migration. Answer. Correct answer. B. Blade servers for their space efficiency and integrated management. Blue book explanation. Blade servers are ideal in environments with limited rack space and centralized workloads, as they offer high memory density, shared power and cooling, and are managed via Cisco UX Manager. Rack servers A offer flexibility but take more space. Tau servers C are unsuitable for data centers due to their size and scalability limits. Hyperconverged appliances D are suited for different use cases. Cisco's UX platform guide highlights blades for high-density applications with tight integration. Question 22. Based on the information gathered during troubleshooting, Isandria observes that traffic from VLAN 30 is not reaching a core router across a trunk link on a Cisco Nexus 9000 switch. She confirms VLAN 30 exists and is allowed on the trunk. Which configuration oversight could still cause this problem? A. VLAN 30 is not configured as a native VLAN. B. The trunk port is in suspended mode due to port channel mismatch. C. VLAN 30 is missing from the switch's VLAN database. D. The router's subinterface for VLAN 30 is not operational. Answer. Correct answer. C. VLAN 30 is missing from the switch's VLAN database. Blue book explanation. Even if VLAN is allowed on trunk, it must also exist in the switch's VLAN database. Show VLAN brief for proper forwarding. If missing, traffic won't be switched or routed correctly. Native VLAN is only relevant for untagged traffic. Suspended trunk. B causes broader issues and is easier to detect. Router subinterface. D would cause upstream but wouldn't stop the switch from forwarding VLAN traffic. Refer to Cisco VLAN configuration guidelines. Question 23. During the process of configuring a SAN fabric, ISTA Secure configures zones and adds multiple initiators and targets in a single zone to simplify administration. However, his storage team warns this may introduce risks. Why is this zoning practice discouraged? A. It causes vSAN merging errors on the fabric. B. It results in floaty timeouts on UX endpoints. C. It increases the risk of data corruption and domain disruptions. D. It prevents port binding between initiators and targets. Answer. Correct answer. C. It increases the risk of data corruption and domain disruptions. Blue book explanation. Single initiator multiple target zoning is the best practice in fiber channel. Including multiple initiators in one zone can lead to domain disruptions, target confusion, and even data corruption during broadcasts. vSAN merging A is unrelated. Floaty timeouts. B relate to login failures, not zoning complexity. Port binding is not prevented by multi-initiator zoning but is less manageable. CISO DS SAN design guide warns against this practice for stability and security. Question 24. While it is true that UX Manager provides simplified server provisioning, Dominique needs to deploy 40 identical servers using UX Manager and wants changes to affect all servers uniformly without reconfiguration. Which approach should she use? A. Apply individual service profiles manually to each server. B. Configure dynamic pools and apply BIOS settings directly. C. Use a service profile template to create server profiles. D. Clone an existing server profile and assign them to all blades. Answer. Correct answer. C. Use a service profile template to create server profiles. Blue Book explanation. Using service profile templates in UX Manager allows centralized management. Changes to the template can propagate to all associated profiles, enabling consistent and efficient provisioning. Manual configuration. A and cloning. D. Own efficient and error-prone. B alone doesn't tie BIOS policies to multiple servers. Cisco UXMA configuration guide promotes template-based management for large-scale deployments. Question 25. The foundation of unified networking, Cisco's F-code technology allows storage and data traffic to converge. Mr. Eduardo notices storage performance degradation on UX server using F-code. Which configuration setting must he validate first? A. That the VLAN is configured as native on all trunk ports. B. That flow control and priority flow control PFC are enabled on the path. C. That jumbo frames are enabled on the FEX ports. D. That ENS and NEP are reachable from UX Manager. Answer. Correct answer. B. That flow control and priority flow control PFC are enabled on the path. Blue Book explanation. FCO relies on lossless Ethernet achieved using PFC and flow control 800 2.1. Without it, frames may drop, leading to poor storage performance or failure. VLAN configuration A is unrelated to lossless transport. Jumbo frames C may help performance but are not critical. Operation ENE D does not affect F-code traffic. Cisco F-code deployment guide mandates BFC configuration for any F-code implementation. Question 26. In light of recent developments in server form factors, Istigave is comparing the network paths of rack-mounted servers and blade servers in a UX domain. What is a key architectural difference between the two? A. Blade servers use top-of-rack switches, while rack servers bypass UX. B. Rack servers connect directly to fabric interconnects, bypassing chassis. C. Blade servers have dedicated management controllers for each chassis. D. Rack servers are only supported on UX C-series chassis. Answer. Correct answer. B. Rack servers connect directly to fabric interconnects, bypassing chassis. Blue Book explanation. Rack servers in UX C-series connect directly to fabric interconnects, while blade servers go through the chassis midplane, then to fabric extenders and onward to FIS. A is incorrect. Blade servers don't use top-of-rack switches. C is not specific to blades. They all have sinks. D misstates form factors. C-series refers to rack form, not chassis model. Refer to Cisco X hardware architecture overview. Question 27. In what ways can subnet planning impact UX service profile deployment? Wafa is assigning IPs for SIMS KVMS and management interfaces on 50 UX blades. She uses a 25 subnet, which best practice will help her avoid exhaustion or conflict. A. Use a 24 subnet and statically assign addresses. B. UAP for all interfaces, including fabric interconnects. C. Reserve a subset of IPs for static assignments and segregate by interface type. D. Apply a single shared IP all SIMs by a NAV. Answer. Correct answer. C. Reserve a subset of IPs for static assignments and segregate by interface type. Blue Book explanation. IP planning should include segregated ranges for SIMS KVMS and fabric interconnects. Static assignment for critical devices and IEP for non-critical ensures control and flexibility. 25 gives 126 usable IPs, sufficient if organized. A. Waste space unnecessarily. B. It is risky for core devices. D is invalid. NAT is not used for SIM management within UX. Cisco UX IP address planning guides recommend segmented pools for clarity. Question 20. The impact of Cisco HyperFlex in modern data centers is evident in its hyperconverged design. Izayaka is configuring a HyperFlex cluster with 3 nodes. She's unsure how storage is distributed. What characteristic of Cisco HyperFlex's design ensures data availability? A. Centralized storage array managed via SAN. B. Dedicated ISCSI volumes per node. C. Distributed file system with replication across nodes. D. Layer 2 only switching to isolate traffic. Answer. Correct answer. C. Distributed file system with replication across nodes. Blue book explanation. Cisco HyperFlex uses distributed storage architecture called HX Data Platform, which replicates data across nodes for fault tolerance. A is traditional SAN, not ICHIA. B is not used. Storage is pooled. D describes network configuration, not storage. Cisco HyperFlex admin guide details how replication across nodes ensures availability and resiliency. Question 29. To better understand OS modularity in Cisco Nexus switches, Mr. Hines wants to isolate software processes for fault resilience. What key architectural design of NXO supports this? A. NNSOS uses a single-threaded monolithic kernel. B. Each feature runs in a separate process to enable fault isolation. C. It relies on iOS process scheduling for compatibility. D. NXOS does not support modularity by default. Answer. Correct answer. B. Each feature runs in a separate process to enable fault isolation. Blue book explanation. NXOS is modular Linux-based OS where each process feature runs independently. If one crashes, others continue unaffected. This modularity provides high availability. A, C, and D are false and misrepresent NSOS architecture. Cisco NXOS System Management Guide confirms process-level isolation as cost. Question 30. The core principles of performance optimization require monitoring real-time metrics. Harper is observing buffer overflows on a Nexus 9500 switch. Which metric is most useful to identify congestion at the interface level? A. EP utilization percentage. B. Output queue drops on interfaces. C. Interface duplex mismatch. D. Air disabled port status. Answer. Correct answer. B. Output queue drops on interfaces. Blue book explanation. Output queue drops indicate interface level congestion where packets are dropped due to buffer overflow. This directly reflects oversubscription or microburst conditions. EPUA won't show interface stress. Duplex mismatch. C causes errors, not congestion. Air disabled. D is unrelated unless violation triggered the shutdown. Cisco NXOS performance monitoring guide highlights queue drops as key congestion indicators.